Hello, fifth graders. I just thought I would say hi so you could see my face for for a minute, so you're not just looking straight at the book right off the bat when I start this next video. What I would like you to do is get out your Into Math workbook pages. We're going to be starting on page 9, lesson 2. What I'm going to do is teach you lesson 2. We're going to stop this video and then I will do another video for lesson 3, so you don't have to cram 2 lessons into one video. This way you could do one lesson, take a break, do the other lesson a different day, but just within this next week to get this work done. I do want to make a note to you guys. I need you to be doing your everything that's assigned to you each week. This is number 1, how I track your attendance in that, how every day when you come to school we have to take attendance whether you're here or not. We can't physically do that with you guys because you're not in the building. However, in order to give you attendance credit so it's not looking like you're absent, you have to do those assignments every single day. So you have to do Waggle Math and you have to do Waggle ELA or Waggle Reading. Even if it's a little hard, Jacob, you still need to do it. You have to get your green light every day, Jacob. Deanna, you are not doing reflex math, but Jacob, you have to get the green light, not just get on to reflex math, but get the green light. And then Sum Dog, you need to be doing Sum Dog for 20 minutes every day. All of those things, so for Jacob, you're doing 4 things every day. That shouldn't take you more than maybe an hour and a half at the very most. Deanna, because you're doing one less thing, it probably should take you about an hour and 15 minutes to do all of those things every day. The kids that are coming to school are here for 6 hours every day. So you can see where, it's not like it's taking you all day to do all of these things, but you do need to do them every single day. I'm going to start letting Courtney know, and you're going to be marked as absent if you're not doing all of those items every single day. This is important, and I really need you to focus and make sure you're doing your jobs as a student every single day, because that's the only way you can pass 5th grade. Is by doing what I'm asking you to do. And then you also need to do the other assignments that are due by the end of the week. You must do the reading assignment, you must do the writing assignment, and you must turn in those math papers. You must watch the videos, follow along, and turn in those math papers. This is part of being a student. And when you're learning from home, it is a little bit differently because you are responsible for making sure you get all of your jobs done. Okay, when you're in school, you kind of can rely on your teacher to kind of be the taskmaster to make sure you get your jobs done. At home, you have to be your own taskmaster. And I really, really, really need you to start pulling your weight and getting all of your work done every single week. Please, 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 and thank you. I'm hoping to see a big change this week in the work that's getting done and turned in. Okay? So please, please, please do what you're supposed to be doing. I know you both know how. Deanna, I know you're doing more work than I'm seeing from Jacob, but you are also missing assignments this week as well. So both of you need to be doing everything. If it's on your assignments for the week, you need to do it. And when it says every single day, Monday, Tuesday, Wednesday, Thursday, Friday, those 4 things, Jacob, and Deanna, 3 things need to be done every single day. Okay? Otherwise, Mrs. Callan and Courtney will be contacted, and then you probably will get contacted by Mrs. Callan. And I don't think you want that. Alrighty, so now I've gotten that my disciplinarian voice out of the way. I'm sorry, but I do need to address that issue. And now we're going to start on page 9 for lesson 2. So I'm going to turn my camera down, and then I got to flip it because it's upside down once I turn it down. All right, and then we'll get started. Okay, so lesson 2, we are going to be using the powers of 10 and exponents. Now, exponents might be a word that you've not heard before. Exponents are similar to when you were first learning multiplication. When you were first learning multiplication, you were learning that multiplication was repeated addition, right? So if I had 4 2s and I would add 2 plus 2 plus 2 plus 2, right, that would be 2 times 4 would equal 8. Well, with exponents, it's not with addition. It's multiple times that you multiply. Okay? So, and we're going to start with the powers of 10 with our exponents because it's one counting by tens is a lot easier. So we start with a digit or a number that's easier to count by, and then we will go to something a little more complex later on. So to start with, when you're done with this lesson, hopefully you will be able to rewrite expressions involving the product of a one-digit number and a power of 10 as a whole number. So, in Spark Your Learning, a local business has set up a website to raise money for a playground. Each donation is $10. So I'm going to circle that $10 because I'm guessing that's probably going to be something that's important. For the first 10 days, the account receives 10 donations each day. How much does the account receive the first day? How much does the account receive after 10 days? Explain your thinking. So we are going to, I'm sorry, I got to zoom in this page that I have over here just so I can make sure I'm explaining this correctly. Okay? So the first thing we need to notice is that we are starting out with how much money? How much was our first donation? Our first donation was $10, right? If I have $10, I can represent that with a picture with one, this is called a long. So we can represent it with one long. For the first 10 days, the account receives 10 donations each day. So that means if I have 10 donations each day for 10 days, I could represent that with a flat because one long would be 10, one flat would be 100. They're getting 10 donations each day. So this is each day. So after the 10 days, if they're getting these each day for 10 days, so you're going to get $100 on day 1, $100 on day 2, $100 on day 3, $100 on day 4, right? And so on and so forth. So if I get $100 each day for 10 days, well, then I'm going to have this much money. What does a cube represent? A cube represents $1,000. So this is after 10 days. So this is each donation. And each day they're receiving $100, which was 10 donations. So this would have been 10 times 10, right? Because they would receive 10 donations of $10. And that's how you get your $100. And after 10 days, so if you have $100 per day times 10 days, that's how you get your $1,000. How much each donation was worth, how much they're getting each day. After 10 days, they're going to get $1,000. What am I noticing about what's happening to my money? My money is increasing by one place value. I started in my tens place for each donation. After 1 day, I went up to the hundreds place. And after 10 days, I'm in the thousands place. So I started out with just a 10. 10 times 10 is 100. 100 times 10 is 1,000. Okay? So what does that all mean? How does that relate to exponents and what all this talk about exponents is? Well, let's first look at this connective vocabulary. You can represent factors using a base and an exponent. Okay, so a base and an exponent. The base is the number used as the repeated factor, so the number that you're going to be multiplying that many times. The exponent is the number that shows how many times the base is used as a factor. So for example, if I'm going to multiply 10 3 times, 10 times 10 times 10, my base would be 10. My base would be the number that I'm multiplying. My exponent is how many times I'm going to multiply that 10. How many times I'm going to multiply that number. So if I know that 10 times 10 is 100, 100 times 10 is 1,000. So 10 is my base number because that's the number I'm multiplying. And my 3 is how many times I'm going to multiply that number, which is going to equal 1,000. So exponent form looks like this, 10. And when you say this in word form, it's 10 to the third, or the third power of 10, meaning 10 multiplied 3 times. Okay? So that's some brand new thinking when we're doing our multiplication. So one bag of playground sand is shown. So you can buy sand in a bag for the playground. Okay? How many cubic inches of sand are in 10 bags? So first we need to notice how many cubic inches are in one bag. Well, in one bag we have 1,000 cubic inches. Use multiplication to show the number of cubic inches of sand in 10 bags. How many cubic inches of sand is this? So I need 10 of these bags. So I know I need 10 bags. How much is in each bag? 1,000. So instead of adding 10 1,000 times, right? Or adding 1,000 10 times, I can multiply it. So 10 times 1,000 equals, remember when we talked in the last lesson, when you go up 10, you're moving one place value bigger, right? Anytime you're multiplying by 10, you're getting bigger by one place value. So 10 times 1,000, we're in the thousands place. Now we're going to be moving to the, I hope you're thinking 10,000s place. So 10,000, and we're going to call it cubic inches because that's our label, right? Cubic inches. Because that was the question, how many cubic inches of sand? How can you write 1,000 as a product using only factors of 10? Well, if I want to get 1,000 as my answer, product means your answer when you're multiplying. Factors of 10 those are the numbers you're going to multiply together to equal that product. So how many 10s do we need to equal 1,000? Well, I know that 10 times 10 equals 100, right? And I know that 100 times 10 equals 1,000. So how many 10s do I need? I need 2 10s to make 100. So I need 3 10s to equal 1,000. Can you see that? 2 10s equals 100, right? 10 times 10 equals 100. And I know that 100 times 10 equals 1,000. Oh no, sorry, that was 10,000. My bad. I'll look it up there. Stay down here. 100 times 10 is 1,000. So I needed 2 to get here, and I need 1 more to get to 1,000. So 10 times 10 times 10 equals 1,000. So how many factors of 10 are needed to write 1,000 as a product using only factors of 10? So I need 3 factors of 10, right? These are each a factor. Each one of these is a factor. So I need 3 of those. 3 factors of 10 to equal 1,000. So if I need 3 factors of 10 to equal 1,000, how many factors of 10 would I need to write 10,000 as a product using only factors of 10? If I need 3 for 1,000, I must need 4 factors of 10 for 10,000, right? I would do one more. 10 times 10 times 10 times 10 would equal 10,000. I would be going up one more place value. So how could I write the number of cubic inches of sand in 10 bags in exponent form? Remember, we talked about this over here. If I have each one of these as a factor, that's my base number is my 10. How many times do I have to multiply it together to get my answer? Well, I want to know 10 bags. I know that 10 bags is 10,000. So I know I'm going to do 10 to the 4th cubic inches. Because I said I need 4 factors of 10 to get 10,000. I know I need 10,000 cubic inches, so I'm going to do 10 to the 4th factor cubic inches. So this would mean I would multiply 10 times 10 times 10 times 10, which would equal 10,000. My base number is the 10. How many times am I multiplying it together is my exponent, which is raised up just a little bit. It's small, and notice how it's up a little higher. I don't write it right down here because it would look like 104. This is how I want to write it. A power is the number that results from repeatedly multiplying a number by itself. How can you write the answer in part D in word form? So how would we write this? Remember word form? This one is the 3rd power of 10. This would be the 4th power of 10. Okay, so let's move on to step it out. A company sells 6 power of 10 cell phones per week for 7 weeks. The total number of cell phones sold is 7 times the 6 power of 10 phones. How many phones is this written as a whole number? So we need to write 7 times the 0 power of 10, 7 times the 1 power of 10, 7 times the 2nd power of 10, 7 times the 3rd power of 10, 7 times the 4th power of 10, 7 times the 5th power of 10, and 7 times the 6th power of 10 as whole numbers. So if I'm looking at this first one, just this first one, 7 times the 0 power of 10. Well, the 0 power of 10 would be just 1. Okay? It's just 1 because I'm not multiplying by 10. I'm multiplying by just 1. So 7 times the 0 power of 10 is 7. 7 times the 1st power of 10. Well, the 1st power of 10 is just a 10. When you have a 1 here, that just means it's a 10. 7 times 10 is 70. 7 times the 2nd power of 10. Well, 7 times 10 we said was 70, and 70 times 10 is 700. I want you to notice what's happening to your place value. 7 times the 3rd power of 10. 7 times 10 is 70, times 10 is 700, times 10 would be 7,000. 7 times the 4th power of 10. That equals 7 times 10, which we said was 70, times 10, which was 700, times 10, which was 7,000. So now times 10 is 70,000. 7 times the 5th power of 10 equals 7 times 10, which is 70, times 10, which is 700, times 10, which is 7,000, times 10, which is 70,000, times 10, which is 700,000. 7 times the 6th power of 10 equals 7 times 10, which is 70, times 10, which is 700, times 10, 7,000, times 10, 70,000, times 10, 700,000, times 10. I hope you remember from 4th grade what comes after 100,000. We'd have 7 million. And Jacob knows I like to say million, right? So, how many phones would be sold in 7 weeks? 7 million phones. So now, here's where it's hopefully not looking as confusing. What pattern do you see between the number of zeros in the product and the exponent? If I have a 0 as an exponent, I'm not going to have any zeros in my answer. If I have a 1 in the exponent, look at, I have 1 0. 2 exponent, I have 2 zeros. 3 as an exponent, 3 zeros. 4 as an exponent, 4 zeros. 5 as an exponent, 5 zeros. 6 as an exponent, 6 zeros. Do you see the pattern? Now this is when I'm using 10 as my base number. It will change with other numbers there. But for right now, while we're just using 10 as our base number, you can look at your exponent and you're going to know how many zeros you're going to need after the number you're multiplying by. So it probably looked a little confusing at the beginning, but now that you see this, I'm hoping this is more clear. That you can look at these exponents and see how many zeros you need after you multiply, right? 7 times 10, you know, is 70. I need 6 zeros after my 7. Check for understanding. So the attendance at a music festival is 100,000 people. Write the number in exponent form and in word form. So let's count our zeros. 1, 2, 3, 4, 5. So what's my exponent form going to be? The 5th power of 10. Remember that 5 is going to be tinier. It's going to be about half the size as your number, and it's going to be written above the number to the right of it. So this is the 5th power of 10. So remember what we did up here with our 7s. Now I've got a 3. And I want to multiply 3 to the 4th power of 10. How many zeros do I need? I need 4. So 3 times 1 is 3, and then I need 1, 2, 3, 4. Now where's my comma going to go? Remember, I count 3 in. So this is 30,000. So I started in my ones place and I went up to my 10,000s place by going up 4 to the 4th power of 10. 7 to the 2nd power of 10. Well, we did this up here. 7 to the 2nd power of 10 is 700. 2 zeros after that 7. And 8 to the 5th power of 10. So I need 1, 2, 3, 4, 5 zeros. And make sure I put that comma in there. Remember, every group of 3 from the right over, right to the left. Alrighty. So hopefully it's not as tricky as you were thinking it might be when you first started. So now when you get to this part where it says on your own, if you feel comfortable and you want to pause the video and try to do it on your own and then come back to the video and check your answers, you can. Or if you're still feeling a little unsure of yourself, go ahead and follow along with me. So those are the 2 choices you have. Alrighty. The population of a city is 1 million. write the number in exponent form and in word form. So we know that this is going to be, how many are we going to do? How many powers? 1, 2, 3, 4, 5, 6. The 6th power of 10. Count those zeros. That's going to be the best way to figure this out when we're using tens. So 1 times the 2nd power of 10. How many zeros am I going to need? I need 2. 100. 5 times the 3rd power of 10. How many zeros with my 5? 1, 2, 3. 2 times the 4th power of 10. How many zeros? 1, 2, 3, 4. All right. Number 9, attend to precision. What is the value of n? That means an unknown variable in the 4th power of 10 equals 10 times 10. The blank power of 10. We don't know what power of 10 it would be. So if we're doing the 4th power of 10 equals, how many 10s are we going to need? Well, this 4 tells me I need 4 10s. So I'm going to need to write 3 more because there's 1 already here. Now if I've already written one of my 10s, how many more do I need? I need 3 more, so I need the 3rd power of 10, right? These 3 10s is the same as the 3rd power of 10. So the value of my n equals 3. My variable that is missing is 3. So how can you use patterns in the number of zeros to find the value of the unknown exponent? And 9 times, we don't know how many powers of 10, equals 900,000. So I could look at my zeros, right? And I'm going to count how many zeros I have. And the number of zeros is the exponent. So in this case, it would be 9 times the 5th power of 10, which equals 900,000. And number 11. The local business raised 8 times the 2nd power of $10 after 8 days, and 1 times the 3rd power of $10 after 10 days. How much was raised during the last 2 days? Write your answer using exponents and show your work. Well, we know that during the last 2 days, I'm sorry, this is confusing me a little bit. Oh, okay, so this was after 8 days. So we know that after 8 days, they raised 8, the 2 power of 10, so that would be 8 times the 2nd power of 10 would equal 800. And after all 10 days, they raised 1 times the 3rd power of 10, which is $1,000. So how much was raised during the last 2 days? Well, if I take $1,000 minus $800, I'm going to get $200. And how would I show that answer using the power of 10? It would be 2 times the second power of 10. So first I had to figure out what was sold during 8 days. This was after the full 10 days. So what was missing? The last 2 days. So I had to subtract these two to figure out this was what was sold the last 2 days. And there it is in exponent form. 2 times the second power of 10. Alrighty, so I would like you to do lesson 1.2, the black and white sheet for homework, independent work. Then you will need to either take a picture of it, both sides of it, and send it to me, or send the papers back to school to me by the end of the week. And I am going to do the video for lesson 3 as well, so you will have lessons 2 and 3 to do this week. Alrighty, so I'll be recording the next video very shortly. Alrighty, thank you.